The following content has been provided by RWTH Aachen University.
All right, welcome everybody. Good morning. Welcome to DIS1 today. We're going to have some very interactive, exciting, fun stuff to do today. So let's jump right in. Before we do that, quick review of what we talked about last time. We went through a technology life cycle. Anybody remember what those different phases were? I'm just going to call up people at random to get this going, unless somebody wants to raise their tiny blue hand. All right, Sarah, you're looking right at me here, so why don't you start?
Yeah, we had the enthusiast phase, I believe, which was some sort of a hobby phase, not really professional, but the professional one was the professional phase, as they're called. And then we had the consumer phase. And lastly, we have the newly invented Baroque phase.
That's right. Okay, so those were the phases that looked like, had different aspects that were important of the technology we're looking at. Next up, we were looking at a couple vision videos that were from the past, trying to look into the future. I want to hear what were the key advances that were proposed by Put That There, the video that was done by MIT in the lab, not the black and white one, slightly newer one. Anybody got any ideas? Put That There. Yeah, Sarah, go ahead.
I think what was special was the speech recognition. And more importantly, it was sort of natural speak recognition. It was not only giving commands. And also the fact that they were pointing at some objects and to move them. And it was not just with some sort of cursor or a mouse or something like that.
Right. So the natural speech really came more with, the Apple Knowledge Navigator. When you look at the Put That There, this was still, these were normal sentences, but they were very structured, like put the blue cruise ship east of the Bahamas. So it was not, I would not call it conversational, but it was continuous speech recognition as opposed to just single word commands, for example. That's right. And the combination with the multimodal interaction, right? So pointing and voice, as you were saying. All right, so then we have the Knowledge Navigator, obviously continuous, conversational everyday speech recognition. Other things that were unique for the Apple Knowledge Navigator. New interaction paradigms that were proposed there. These didn't exist, right? But they were being envisioned for the future. Any thoughts, Jasper, maybe?
Yeah, I thought about real-time analysis of data.
Yeah, it was definitely going through. It had a lot of understanding about like the current literature out there on a research topic and was able to answer very fuzzy queries on that. Okay. Next up, we had the UbiComp device classes that Park proposed for ubiquitous computing. Those were 3 different classes. Which ones were those? Tejasvini, how about it? It's a longer video with people hanging out in an office, interacting with different sized devices in UbiComp.
They had the, I don't know how to describe it. So they used all the different presentation.
Yeah, so there was a presentation board, like a big whiteboard size thing. That was the biggest form factor, right?
Yeah. And like, I think they were moving around a lot of the elements or like the objects on that screen. So Yeah.
And not just on the screen, but also up and down from their individual tablets, right? So there were tablet-sized devices, foot-sized devices, as they called them. There were the yard-sized devices that they called them, and the inch-sized ones, right? The small tabs, right, that they had.
Yeah.
So today you would probably say similar to your smartphone, tablet, and TV or interactive whiteboard. Okay, and then we watched the Starfire video. This was a longer one, where that lady was trying to sell her new idea for a new electric car to her company head honchos. What were the key, maybe HCI innovations there, new interface innovations there, but also messages on how the process worked? Either of those. What did you take away from that? Yeah, Christina, go ahead.
Yeah, the key takeaway were there were many things. First of all, one was like taking a video and trying to capture the movement of this man, and then making and putting it in another video, or at least in another picture. So
right.
which is, I think, not up until now not really doable, but at that time up until now. And also the interaction with the camera at the car, where she moved some mobile device, and the camera moved accordingly, and that remotely. I think that's also really new. So
definitely,
yeah.
Right, and maybe the workstation that she was working on, what was unique about that?
It was a curved station, so the desk was also like when she put it, she could it was on the bottom of the desk, and it was up, and it was and also the whole screen was somehow curved. So I don't know why they did it like this, but I think you're more into this view where you can everything see when you are sitting at a curved screen. But yeah, that was also very new.
Okay, yeah, good. The curved screen was definitely the most striking feature, maybe, of the hardware of the workstation. Kaya, anything you want to add?
Yeah, there was a new function of the workstation, which was the scanning thing that I don't know her name anymore. She could put the newspaper on it and swipe over it, and then the desk have scanned it, so she can use it.
Exactly. Yeah. So that was the scanning option there as well. Marta?
Yeah, and what other unique things about their prototype was that they tried to show the flaws, and they tried to be realistic in the prototypes. For example, about that scanning part, when the sandwich was mistakenly gets scanned, and
Or the watching people getting delivered flowers and proposing and so on, so privacy issues. Having all those things. Exactly. Yeah, good. So that actually leads to a second part, right? The first part was, what were the key suggested technical innovations that people might expect from office systems of the future? And then there was a second set of messages that to take away from the Starfire video, which is, if you have to do a video prototype, then what are some ideas on how to best do that, right? And how to avoid falling into certain traps, like imagining technology to always work perfectly, like you were just pointing out, Marta, or also basically assuming features without really planning ahead what the system is going to be able to do and not do. And so there's a couple of messages there that you also find in the short reading assignment around the Starfire video prototype. from the Kai paper. And also some very, you know, mundane recommendations on how to save money by just, you know, shooting things where you don't need to show the exact interface, but you show people's reactions to it. All right. So today, we're now going to move into sort of the third part of this class. We've covered the history of HCI and some visions from that time and the phases of technology. And that kind of wraps up our sort of part 2 of this class. And now we're going to move into this third part of the class, which is, which is the development process. So we've covered these two, and now we're going to go into how do you actually iteratively design prototypes? How do you observe users? How do you do idea development? How do you prototype without starting to write code from day one, which is going to be very unusual for you computer scientists out there? How do you run user studies and evaluations? And how do you write down what you learn about the interaction and specify it in a way so that it can then be implemented? In the 50s, people started writing bigger pieces of software, and there was a model that had been developed that was built around sort of, you know, analysis, design, implementation, test, and maintenance, like the old waterfall model, right? It's from the 50s, but it's very idealistic. So we know since around the 1980s, when software became bigger and bigger, that this is really not how you can work, right? So this is known since the 80s that this is not the best way to do it because we are really making a lot of assumptions here, right? We assume that we never need to go back from our implementation and test to redesign our system, and that's just not right, because usually, you know, a couple things can happen. A, when you start out and you build something, and let's assume you've got a perfect picture of how everything needs to work, and then you huddle down and you write the code and you develop the software over like a year or so, and all of a sudden, you know, Corona happens, or you know, the iPhone gets introduced, and all of a sudden everybody wants the iPhone to be part of your software solution and be able to access it with their mobile devices. Or, you know, with COVID, all of a sudden you can no longer assume people are meeting in person for a particular piece of software that you are designing. So assumptions around your software can change that you're building, and that's reality changing. But even if that's not the case, usually you never have a perfect picture of what you actually need to do, because you are learning about the problem as you are working on the project. So when you begin and you talk to your users for the first time, you try to figure out, okay, what is it that we need to develop for, you know, this particular piece of software? Then you don't have a complete picture of what is actually needed. So you need to be able to backtrack. Oftentimes we've got very abstract user scenarios, right? For example, you know, let's assume you are supposed to develop a very simple word processor, right? So your assumption is, oh, somebody sits at a desktop, you know, and is typing on a perfect keyboard and is alone and is working on one document, right? And that's your ideal assumption. And then in reality, you find out, no, people have like 10 documents open at the same time. They're cutting and pasting stuff from other applications into it. They get disturbed, they get distracted, then they need to find their way back into the software. Maybe they need the software to actually also link to their calendar. So a lot of realistic assumptions you just don't know about, because your initial scenarios of use are not detailed and realistic enough. And the problem with the waterfall model is, if you go down this waterfall and you have developed things all the way to the, you know, the testing phase, and then you discover that your users say, well, the software isn't crashing, but it's really doing things in a way that is completely against the way that I need it to work, right? Then it's super expensive to fix that, because you've already paid the expensive developers, you know, to write all that code, which you're now throwing away to do it differently. So waterfall model, bad idea. That's why you want to actually find these big flaws in your design early on and get rid of them before you spend lots of effort and money into coding complete systems. And that's why since around the 80s, we know that we have to develop things in an iterative fashion. There's lots of different words for this. Some people call it the, you know, the artifact, the task/artifact cycle. Or, you know, Norman has this iterative process covered in the human-centered design process in his book as well. We've introduced this in this class as the DIA cycle of designing something, implementing it, and then analyzing the results, what you've implemented. And note that implementation doesn't necessarily mean that you're coding. It may just be implementing in the sense that you scribble a user interface design, a sketch on a piece of paper and show it to a person to see if your thought process makes sense, what you're trying to build. And analyze usually means that you're talking to users, and not always, but in most cases, you're actually testing your system, your prototype, your sketch, your early design idea with people. So you could also call it the design, implement, evaluate cycle, but that would have been the DI cycle, and I found that a little bleak as an abbreviation. So we're going with DIA. So let's look a little more in detail at this, because you're going to see this a lot, right? The DIA cycle will be at the basic of all your activities now. One of those iterations is kind of like a tiny little waterfall model, right? As you saw, the waterfall model also goes from a design to an implementation to an analysis and testing phase. So the DIA cycle means that one of those iterations is going to be very quick early on. You do lots of these iterations over the course of a project. And with each iteration, things change, right? With each iteration, first of all, your design obviously becomes more concrete and more precise, right? More like the final product, if you want. And the idea is that you uncover smaller and smaller problems as you go down that, down the many iterations. So basically, in the first iteration, you try to solve the really big questions, like, do we even need software, or is this a different problem? Or if we do need software, do we need a web-based solution, or is this something where people need a mobile device to carry around? What's the problem, really? Trying to really understand the problem and settling down the big cornerstones of your design. And then as you go through your iterations, you find, you develop more and more details in your prototype, and you flesh it out more and more. And the feedback you're getting from users, hopefully, will then be on smaller and smaller issues as you move down that path. So what you really want to avoid is that you make all these big decisions in the beginning. You don't talk to your users enough to find out if you're on the right track, and then you go off on a tangent, developing lots and lots of stuff, and then you discover that one of those basic fundamental decisions was completely wrong. We unfortunately still often see that in commercial software being developed, because the waterfall model is still something that a lot of people tend to go for simply out of these days, I would say out of laziness, or because they don't know any better. They didn't take DIS1. That's one of the problems. So as you go along and you fix smaller and smaller issues, at the same time, of course, your implementation, your prototype becomes more detailed and technically complex. It can really move from a piece of paper where you scribbled down a little sketch of a UI down to a full-blown prototype that already has working functionality built in software and hardware maybe. So we want to fix the big design bugs first, the small ones later, right? That's the key idea here. We're not just dreaming this up too, right? The DIA cycle. If you look at the ISO, the International Standards Organization, there's actually a 9214 standard that actually covers the iterative design cycle, and it actually has replaced, if you want, the old waterfall model, which also was an ISO standard. So this is really recognized by industry now as something that iterative user-centered design is an ISO standard. It's not something we're just making up. How is this going to work in your projects? You will have a particular project topic this year that you're going to learn more about in due course, but strengthening and maintaining social bonds is going to be the overall topic here. And as you go through your project, we have all these steps and multiple iterations in your project. So you will go through several DIA cycles as you do your project this semester. We've got these several different milestones for brainstorming an idea, storyboarding it, prototyping it, doing user observation with it, and testing it, and so on. And this will feed back into your project design, and you will improve your design further. You're not going to get, let me say that right away, you're not going to get to a complete finished functional app or service or website or code this semester with DIS1. This is not the goal. You got plenty of opportunities to code elsewhere in this in this program that you're in. And this is not about coding. This is about learning how to find out what you need to code later, right? So it's not about how to write software, but what software to write. This is, if you want to describe the job of a designer in like one sentence, it's designers don't care so much about how you do something, but they care about what you should be doing in the first place. What is the problem that we really should be solving? What is the solution we should really be going for? And then comes all the implementation details on how to make that happen technically in detail. Let's unroll this DIA cycle real quick here. So as you start your project, you will initially brainstorm maybe different representations. You'll be talking to users, of course, and your design activities could also include, roughing out the interface style. Like I said, maybe, app, website, hardware device, whatever it is that you're trying to do, collaborative software piece. And your implementations as such will often be very low fidelity. So, quick and dirty paper prototypes that you often sketch with pencil and paper in your hand, real analog tools. And there's a reason why we go analog. I'll explain that in a minute. As you move on, then you have, of course, lots of feedback in your cycles. You do like a task-centered walkthrough. You redesign your software after you've done that walkthrough with users. And then you might, do more testing to fine-tune your interface and your screen design. You might run heuristic evaluations. All of these things will mean something to you in a few weeks when we've gone through all these techniques. And we'll be doing this around medium fidelity prototypes, so they might still be on paper, but they will be maybe a little advanced, or maybe they are, a PowerPoint slideshow that you click through with screens, for example. And then as you move deeper and deeper into this, you're going to get into high fidelity prototypes where you really start doing usability testing for the detailed questions that you might still need to answer, the fine tuning of your interface, until you then finally have a working system where you move into production code, and you do first just limited field testing and then alpha tests, beta tests until you have the final project running. And of course, we'll be revisiting this again in the prototyping classes, so don't worry about this too much right now. But the idea is basically that you will be tending to use more and more users in your tests, because the problems you are trying to unravel are going to be trickier and trickier to find and to pinpoint. In the beginning, you've got obvious issues where you're like, just haven't understood what the problem of the user base really is, right? You're developing, let's say, we just got new telephones. That's why I'm going to use this example. We got new telephones at the university. The first question you're going to ask, of course, is what is it even that people demand of an office telephone today, right? What are they doing with these things every day? What do they do every week a couple times? And what do they do several times per day? What are the key functions that they really need, and how do they need those? And then in the end, when you are like, when you figure that out, you don't need to talk to 1,000 people for that, right? It's enough to talk to 10 or 20 to figure that out. And then, but in the end, when you want to fine tune things like, some people have last names where they have umlauts and these are hard to type in on the telephone keyboard, so we need to fix that. Those are things you can only discover then when you do more and more user testing for the finer, trickier, detailed problems. As I said, Norman also covers this in a way. So in Norman's book, you find it's called the human-centered design process, which in which the idea generation is very similar to our design phase that we talked about. And prototyping, of course, is what we call implementation. And the testing and observation together are basically our analyze phase. So you can see it's the same philosophy that puts the user at the center of your design process. I liked one of the quotes that I want to mention here from Don Norman, is that he at one point said, when he goes consulting, because often he gets called in to solve issues with the software. And often people say like, oh, this is our problem, please help us. And he says, I never go in and solve the problem I'm asked to solve. What is behind that? Well, it doesn't just mean that he goes off and solves a completely different problem, but it means that he performs what's called root cause analysis. And this is an important thinking mode that I want to get you people in. In the real world, you often need to discover problems. They are not written down on a piece of paper for you. And we as engineers are not trained to do that very well. We are trained to solve problems. And designers are trained to find problems. So this is a bit about this, like, what you build and how you build it, right? Engineers are good at how to build something. Designers are good at figuring out what needs to be built in the first place. So as an engineer, you often tend to rush in and, somebody says, I've got this, I've got these issues with my smartphone when I charge it. It gives me these weird messages every time I charge it, and you rush in and you solve the problem, and you kind of like make the message go away after 5 seconds instead of sticking around on the screen, so that it's not as annoying anymore. But the problem really was maybe that the whole charge management was designed badly, so that this message that was originally meant to only pop up once a month now appears, every 3 days, and you haven't actually solved the real cause of the problem. That's what we mean with root cause analysis. You go deeper, right? So instead of just rushing in, you ask, is the problem that I'm being presented with, is that actually the root of the issue, or is there a deeper connection behind this? And then you define the right solution to that, and sort of go in and solve the root cause of the problem at hand. Now, another example, let's say you're designing a washing machine, and you, when somebody is using it and says like, oh, but I have trouble, I have trouble using it because I don't know how to turn it on. You don't just make the on button bigger, right? That's not the idea. But you might ask yourself, well, is turning on and off even necessary for this device, or can it figure out by itself that it needs to be turned on when somebody, I don't know, opens the door to the washer or something? And this needs to be done early, right? Because we are at this point of, what's the problem we should be solving anyway, right? This needs to happen early. If it doesn't, then you waste lots of time writing code, building prototypes, implementing stuff, addressing a problem without ever understanding that you're really only fixing symptoms down the line when the real issue is somewhere further ahead. Okay, so here's the first in-class exercise that I want you guys to think about. I've given you a few examples here. A few more maybe to get you thinking about this. You could say, if somebody comes to you and says, oh, I really have trouble, waking up in the morning from my alarm clock. You could say, all right, I'm going to build you a louder alarm clock, right? That will just, ring you out of bed with lots of noise and blinking, flashing night lights and whatnot. The root cause analysis might, however, say maybe, if you got trouble getting out of bed in the morning from the alarm clock, then maybe you're not sleeping right. So let's look at your sleeping habits and see if we can improve your sleeping habits and your environment where you sleep. Make it quieter, make it darker during the night, those kinds of things. Make sure that you don't eat 2 pizzas before you get to bed, or watch horror movies until 3 a.m. Those kinds of things, right? So you would help people find a better sleep pattern, so that then a perfectly normal alarm clock is absolutely fine. So you've discovered a root cause behind it, and you can see oftentimes it's multiple jumps, right? You're like, oh, okay, you can't wake up in the morning. Oh, let's see why that is. Well, maybe it looks like you're not having very sound sleep. So why is that going on? Oh, your eating habits. It could all be connected down the line, and you're trying to find the root cause analysis. Or to give you maybe a different example, for a long time people were designing cables and always try to, let's say you get a cable, a USB 2 cable, right? And you look at it and you're like, oh my God, this is stupid. I don't know which way is up on this cable, right? Which way to plug it in. Now, the quick fix that an engineer might be like, okay, we're going to slap a USB logo on one side and we're going to standardize on which side that is. So all you need to do is look at your cable, find the side where the USB logo is stamped on, and then you know which way to plug it in. Well, that ignores a couple problems, doesn't it? For example, that doesn't help you when you're plugging in a cable behind your computer where you're not even seeing how the socket is labeled, or the socket might be mounted the other way around, or you might get a fancy design company like Apple printing all these things in light gray on white, and a lot of people can't see that, what they're printing on there. So lots of issues with that solution. It's not really solving the problem. The problem is really that the plug is, looks like it could be put in both sides. And there's a couple different solutions, right? One solution that many vendors have gone down is to make their cables and plugs clearly have a shape so that you can only plug it in one way, right? That's the case, for example, for micro USB or something. If you look at the plug, you can kind of see that it's wedge shaped and it only fits in one way. Still, yeah, it's a maybe better solution than the labeling idea, but still, we haven't really faced the root cause, right? The root cause is, why do we have all these different stupid cables, right? So you could do a couple things. You could design a plug that can be reversed, right? Like the lightning cables or the USB-C cables. That's a great solution to remove the issue of, I don't know which way this cable fits in. Okay, let's hear some ideas. Who's got an idea of something that they would consider an everyday problem with technology or with something else that needs a bit of root cause analysis to actually understand the real issue behind it? Look at my participant list here. Hold on. Yeah, Aparna, go ahead.
This is a problem I think most of us having Mac would face it. The charger is really heavy, and if I plug it into the socket on the wall, it so happened that my socket was really loose and I couldn't put it in properly. So what I did was I went ahead and got an extension cord. Now the problem with the extension cord is that it's really light, so the MacBook charger would slightly tilt because it is really heavy. And then I had to put it the reverse way so that it would stabilize and stay properly. Now this is something I find really annoying and I have to go through every day. And yeah, so the root cause analysis for this would be, I think the charger's size can be made, can be standardized. And I do know that Apple came up with a really ingenious solution for it, which is you can get another extension for the charger, which supports the 3 plug points. Yeah, they said, you know what, give some more money and buy this. But yeah, so that's one problem.
This one, right? Yes. Exactly. Very useful piece of technology. Used to be in the box with the old Big Macs when you bought one. No longer. Yeah. Good. Okay. So yeah, root cause analysis tells you that it doesn't help to kind of prop up your charger or do hot fixes, but you actually have a different issue. Yeah. Oftentimes that's a good example. Hot fixes and these little quick fixes are examples where you just don't want to deal with the root cause analysis and you're just trying to get the symptom to go away.
Yeah.
Anybody else got one? Yeah, Victor, go ahead.
Yeah, I thought about the problems that every Mac user has at the beginning. Like when you want to share, for instance, the screen in Zoom, at first time you need to exit Zoom and then start it again. And it's really like things that's irritating me, like for every app. What the problem here is, it's not like just exit and turn back, it's the problem of privacy. So you need to allow some things before. Do you hear me?
Yeah. I'm so okay. I couldn't quite follow with the problem, but let's assume the problem exists in your configuration. So what's the root cause analysis? What's the real problem?
The real problem, I think that the privacy were not asked me at the beginning of the usage when I even install the program. And I need to care it about when I really need exactly some functionality at the specific point of time.
So maybe better dealing with privacy checks at installation time and first launch time.
Yeah, like it's already implemented in iPhone at the beginning when you can press OK, allow, and you don't need to exit or do something else. Like it's really weird behavior for me.
Okay. Okay. So the fix would not be to address this particular one issue, but really rather get into a more of an installation time check of security.
Or even when you buy your MacBook, you can set my default privacy policy, and then, okay, I let everybody share my screen.
Jasvini, you had another one? Thank you, Victor.
Yeah, so mine was related to a Windows laptop. So the Windows has this horrible habit of continuously prompting you to restart the system so it can install the updates. And sometimes it does that automatically when you're right in the middle of editing a document. So the computer that I was using had a setting that it should not restart in the active hours, like the activity period of a particular user. And so it used to keep prompting for the update, but because like I was ignoring it, a lot of updates were pending. And then finally I gave up and I said, okay, please update the system. But the update never completed properly because this was during my activity period. So, but I did not realize that the problem was because the activity period was, the update was happening in the activity period. So I kept trying to restart so that the update would install. But then finally I changed the activity period, and that was when the restart completed, the update completed.
Yeah, okay, good. And maybe, you know, even one step beyond that would be to say, well, do we really need to reboot our computers all the time for every single small update that we do? Is there a way to do this maybe in a more modular way, just to restart certain services when they're getting updated without requiring that complete sort of log out and log in that puts the user under a lot of extra effort? Okay, we're gonna take one more. Okay, Umar, go ahead.
I think it was like really in 8 years ago, but if you are somebody who is on the telephone for a very, very long time and has to do some calls, you either put your telephone on your ear or you do it on speaker. So they invented this Bluetooth headset you put on one ear. So maybe it prevents you from having your telephone on the ear all the time, like for 1 hour or 2, or putting it on speaker so everybody can hear what you are saying and what the other person is saying.
Ah, good one. Okay, so the sort of the initial solution of not wanting to hold your phone to your ear all day was just to put it on speakerphone and then everybody would be hearing it. But a better solution is actually the root cause is I don't want to have this heavy thing here.
Yes.
Instead have a much more lightweight thing that you can wear. Yeah, okay, good. All right, so you get the idea. So what this means is that oftentimes in the process of design over time, this is the x-axis here, the amount of alternatives that you're looking at for your problem changes. That's the y-axis here, right? So in the beginning, when you are discovering your problem, you are expanding from a starting point into many different versions of your problem, many different questions that you could be addressing and that you could be answering. And then you understand what we call the problem space, and you gradually limit this down to define, okay, this is the thing that I actually want to deal with. And then you develop something for that actual root cause analysis found problem, and you expand again in the solution space. You don't just start with, this is the solution to it, and I'm going to run down this rabbit hole and do it this way and not look left and right. No, again, you will be expanding into several options. You're exploring now the solution space, which is the second yellow square here, to understand which of the many solutions are actually best attacking the problem. And then once you found the right one, at the last quarter here, then you limit it down, you zero in on that solution, you build that out into a fully working prototype and functioning system in the end, and you deliver that. That's one way to look at it, called the double diamond model of design, also from Norman's book. Of course, each of these steps here that we're talking about goes through this, user-centered design, this DIA cycle in turn, right? This is also, for example, something that the British Design Council has officially sort of ratified as a good approach. What you've also, I'm sure, seen pop up for the last, I would say, 10, 15 years or so, it has become sort of almost a standard way of addressing these kinds of issues, is the concept of design thinking. We're not going to do a full class on design thinking here. That would be its own probably 6-credit class. But what we are actually doing in this DIS1 class, in this second phase or third phase now that we're in with this project, is very much like what typical design thinking activities require. So kind of without knowing it or without calling it that, I've been teaching design thinking since, I don't know, 1998 or so, because it actually covers these following processes. First of all, you empathize, and empathizing means understanding who your user actually is and what matters to them. Like understanding and sort of feeling with the user, understanding the problems that they have. The next step, then, the defining step, is this, understanding what are their actual needs derived out of your analysis of your user base and their and what matters to them. The ideation is this phase that we also call the design phase in the DIA cycle. Developing ideas, wild ideas are encouraged. Brainstorm lots of crazy ideas. You then narrow down on something. You prototype it to show your idea, and a prototype is just this rough draft of your ultimate thing that you want to do, and then you test it. You find out, you go to your users, you see if your idea, your prototype that's based on your initial idea actually works or doesn't work. So design thinking is not a waterfall, right? It's not, you don't just go down this line once, right? You actually have to at least go, ideate, prototype, test. That's basically the DIA cycle right here. But oftentimes you find yourself understanding more about your users and learning more about them and their actual needs. So your target tends to also shift a bit, right? Hopefully you're zeroing in on the problem, but it's not a straight path. It goes, in little sideways. So design thinking, these are all activities happening in a design thinking process, but they happen many times, right? Whenever you need to go back to an earlier stage, you do that. The way that I like to phrase this, so I'm going to tell you 3 questions, and I want to make sure that once you've taken this class, if I come to your house and wake you up at 3 a.m. in the morning and I say, what are the first 3 questions you're going to ask when you are signed onto a new project? And I want you to know that you are going to ask the following 3 questions, right? So these are like super important. The first 3 questions you need to ask yourself whenever somebody asks you to design a solution, a technical solution for somebody, is who is it for? Who are the users? So really understanding not just, oh, we need a new email system, but okay, who's going to be using this? Or to give you another example, like with the phone system that that was introduced at RWTH, who is actually using these phones on a regular basis? Right? And it's not just, that team in the IT center that happens to be ordering the new phone system. They can't just go by their own needs, but they need to understand that they've got a huge user base out there with diverse needs. They need to understand this and figure this out. Second question, after you've understood who are your users, is what do they actually want to do with the system? Right, so what is it that people actually want from this system? Not just assuming that, yeah, of course they will want 3-way phone calls. And to give you an example, we have video calling now on our office phones. I haven't met a single person that I've talked to that actually wanted video calling on their desk phone. They said, like, if I want a video call, I use my laptop, right? It's much better anyway. Bigger screen and so on, and I can work on documents while I'm looking the other person in the eye. Now we've got desk phones that have a little video camera on it that you kind of like look at it at an awkward angle, and it's kind of like, yeah. Anyway, so nobody was really asking for that to be there. But it's still in the system, right? And this is something you want to avoid by really asking people early on, what do they actually want with the system? Hannah, go ahead, you got a question?
No, I didn't have a question. I just wanted to say, because you talked about the office phones with the video, and actually in my department, they're really important because we work with deaf people. and we have to sign them when we call them. So there, the video is actually really important.
Huh, interesting. Okay. See, that's a completely different user base, or different, set of abilities. And you're right. But I guess I should rephrase that. It's not so much that I think, video phones are a bad idea. It's more like whether you pick a video phone or not should be based not just on a bunch of engineers sitting around a table and browsing through the product catalog from the manufacturer, but it should be based on actually talking to your users. Yes, and if they talk to somebody like you, Hannah, they figure out, okay, these people will really benefit from a video connection. Right? And this was actually until sort of the late 90s, early 2000s. This was the only two questions I said. The first two questions you need to ask is, who are the users and what do they want with the system? So users and task, right? And I understood by the mid 2000s, when smartphones became more and more prevalent, that we need to ask a third question, because nowadays it's no longer clear that a computer-based software solution is being used by a person at a desk or something like this. The context is becoming more and more and more important, right? You need to understand where, in what situation people are likely to use your solution, your software, your app that you're developing. And the issue is that a lot of problems actually fail because these three questions have not been answered correctly, right? And all these questions require you to ask, right? You cannot answer these questions just by sitting at your desk and coming up with stuff. That's a really dangerous mode of defining your users and tasks and context, by thinking up things without really having reality checks with people out there who are supposed to use your system. And so the issue is that, especially as engineers, we really like to think of these abstract usage scenarios. We're developing, I don't know, an electronic system to file your receipts on business trips. So the average engineer will say, well, there is this typical, businessman. Usually they don't even start thinking about a businesswoman. And they're perfectly healthy. They're like in their mid-30s. They're technically equipped with all the gadgets that you could possibly want, and they are so eager to try out our new system for filing their receipts online. And of course, they will have perfect receipts for all their purchases on their business trip. And I can tell you, I've done a few business trips. This is completely far away from the truth, right? You end up with like badly printed, crumpled things that come out of a little printer in a whatever shop where you needed to buy some batteries for your gadget or whatnot. And you can't scan them, and then the light isn't there, or your smartphone is dead. And so there's tons of issues in reality that show you that this doesn't work. So we have to make sure that we understand that abstract usage scenarios are not enough. You need to care about your normal user. You need to think about them in everyday situations, including extreme situations, right? So there's a technique that we go through. We'll talk about this in the future, but thinking about extreme users sometimes helps. So people with extreme abilities, or with certain kinds of disabilities, or in particularly extreme context. Can somebody use your system while they're skiing? Just to put out a random extreme context there that will very quickly tell you if you've covered your bases well. If you manage to actually ask these three magical questions and get good, reliable answers to them, you have basically solved most of the difficult parts of your project. But it takes a while to figure this out, and your answers will change over time and will become more and more coherent over time. Now, we tend to think of users as this homogeneous, mass of the ideal user who has no limitations, no special abilities or disabilities, and that's not true, right? To give you even a super simple example, when you and I were to, book, let's say, a trip on the train, right? You go to the Deutsche Bahn interface, and you click through the various options, and it's okay, right? It's a graphical user interface. You can kind of find your connection there. It's not too bad, but it's clearly designed for people who occasionally need to book train tickets. If, on the other hand, you were to work at a travel agency, and or in a big company, and you are booking trips 8 hours a day, nonstop, you would go nuts with the Deutsche Bahn website, right? You would want a very different interface. You would want something that has, quick command line input style, where you can just hack in a couple cryptic codes and boom, you've got a reservation for a particular connection on a particular train into a certain direction and so on. So, and this is in fact true, right? If you look, for example, at airline reservation systems, there are incredibly difficult to use airline reservation systems, but they are incredibly efficient once you've learned how to use them. You type in like cryptic codes. I think it's called the START system, and when you type in these codes, they lead to immediate questions about particular reservations and so on. And people who work in travel offices only use this system. They don't use the the graphical websites that you and I would use to, let's say, book a flight, for example. So understanding users is tricky. We have one thing that we always think about, which is we like to think of newbies and experts, right? And yes, this isn't a dimension. It's actually an important dimension, but it's not the only one. I want to make sure that you understand that just thinking of experience is a little too sort of monodimensional, if you want. It's not the only thing that you can classify people by. But this sort of idea that, and we're going to talk about new experience in the task, right? So are you designing a system, for example, for people who are experts at booking train tickets or who have never booked a train ticket before, right? That would be your difference in experience. Not about experience with a particular computer system, that's a different question, but experience with a task. So a newbie who has no task knowledge, or is a first-time user who has some task knowledge, doesn't usually know the UI of your system, and therefore has a lot of anxiety, right, using a system, because they don't know what it does. So the UI needs to be very simple, has fewer features, has a small vocabulary, doesn't use too many different concepts in the UI, gives you extensive feedback on everything you're doing, gives you ways to step back if there might be a mistake, provides you lots of help and documentation. All this means that it's not the fastest system to use. Just the other day, I was calling the Avis helpline to change a reservation for a car, and you get stepped through a phone dialogue that is very slow, right? It really takes a lot of time, but it's very safe, right? You have very little chance for error and ending up sort of making a change that you didn't want, and that's intentional, right? Because they assume that people will probably be calling this a few times a year at most. And in those cases, it's okay to waste a little bit more time if you provide a safe and not error-prone experience. And you, of course, can't do everything on that helpline, right? You can only change certain things with the automated system. It's very small, right? So small vocabulary, fewer features, simple user interface, and lots of feedback. You read in your booking number, they repeat it back to you, right? That's extensive feedback. Of course, if you do this 8 hours a day, you would go nuts, right? It would be way too slow and way too ineffective to work with every day, but it's okay for occasional use. An average user is more experienced. They know the task well. The UI they might know, kind of, and they tend to forget functions. So many of us are probably average users of lots of the software that we have, right? We often open up apps like for sketching or something only occasionally. And then it's like, oh, wait a minute, where was that function again to do this or this thing? But we kind of get along. And for those people, you need sort of very clear menu structure so we can rediscover the UI and the functions. We need lots of consistency across the user interface because it gets a little more complex now. You want to see and choose your options and commands rather than having to remember and type them. That's why GUIs are so great in this case compared to a command line interface. And you still want error protection, right? Protecting people from mistakes or helping them recover if they made one. And then finally, you've got the expert regular users that know the task well, that maybe even know the UI well that they've been using. This is the travel booking assistant that books trips 8 hours a day. And for those people, you need to focus on speed and efficiency of interaction, right? If you do give feedback, yes, you still provide feedback. You provide less feedback than for the newbie. You provide shorter feedback, not as intrusive. It is not in your face. You know, imagine somebody who changes car bookings every day for 8 hours a day, and every time they enter a system, enter a number into the system, it gets repeated back to them, and they have to confirm that it's the right number. They would go crazy. Right? They would go crazy with any kind of voice-based system because those tend to be very slow in general. So you need to create shortcuts in your user interface, command key shortcuts. You need macros to be programmability, customizability, so that people can pull out functions that they need a lot for their workflow and customize them, create maybe little, automated workflows for themselves, macros, etc., and extend the interface even to their own needs. This is when, when you're typing on a system every day for 8 hours a day, then you want this thing really to be geared to your abilities precisely. But this, newbie, average, expert is not the only way to classify users. There is their background, right? Of course, the name doesn't matter, but age, for example, has an impact, not a perfectly predictable one, but there is a trend, right? So there are trends in memory, in cognitive abilities, also in preferences towards certain technologies that are linked to these demographics, right? The education of your users will matter, right? Do you want to throw a highly complex interface at people who will likely struggle with using it? Of course not, right? So you need to understand what you can expect your users to deal with comfortably so that they feel competent using your system. Then there is the particular experience in computing, right? What do they know about using the particular technology you're putting in front of them? They could be an expert at using Word, but maybe only under Windows and never on a Mac, right? What does that mean? It's usually helpful, if you want to figure this out, to not just ask, are you an expert in Word or are you a newcomer, but ask them, for example, how many hours per week are you using it, right? That gives you a good idea. Do they know certain functions? They might not have seen certain areas of an application yet. And then there's the experience with the task, right? So you can have an amazing architect or technical drawing engineer, but he hasn't used a particular piece of software at all, right? And so there's a big gap here. And finally, there's personality, right? There are lots of different models of modeling personalities, and none of these are perfect. But even using some simple personality profiling models will help you to design things for people that are different from yourself. Because honestly, if you don't consider all these aspects, then you will be building the system just assuming that your users will have your background, your computing experience, which is especially dangerous, your experience with the task, and your personality. And for example, computer scientists are usually known at being, really good at remembering lots of stuff, digging through complex structures, graphs, etc. Coding is, something that requires that. Our minds are geared towards this, but other people have completely different skills, right? That we are really bad at. So understanding, are people leaning to, for example, there's this Meyer Briggs personality indicator, very simple model that has these sort of 4 different dimensions of do they tend to be more introvert or more extrovert? Do they tend to solve things more in a systematic or in a more spontaneous way? Do they have a high affinity to taking risks or a low affinity to taking risks? Are they, do they consider safety higher or less? And are they an early or a late adopter of technology, for example? You can think about what you think about yourself in these things, and you'll probably find that other people will be quite different in this context. This was a couple dimensions of classifying users, and we're now going to talk about how we can actually observe users. There are a couple things that are important when you try to observe users. You need to figure out, first of all, what's the data you want to collect? How will you analyze that data from your observation? Who will you be observing? So identifying who that is. And then it's often very useful to have a triangulation. So for example, not just observe people using your software, but also talk to them, right? This is taking two different approaches, hearing what they think they're doing and then actually watching what they're doing. That's called triangulation, using these different methods to confirm what you've observed. And an observation is something like a prototype that you need to often do a pilot of, like an early test, right? So you often do a debugging round of running a sample interview with a friend or something to debug the process that you're going through. To give you an idea, you might actually say, as a simple observation framework, what you need to understand is who are the people, as you said, the users that you are observing, using some technology. Where are they using this? This is part of the context. And then what are they doing with it, right? What's the task that they're doing? So you got people, places, and things. And each of these, of course, you would be writing down when you do a user observation. This, by the way, you can find in Jenny Priest's book, Interaction Design. That is a nice additional textbook on HCI that's more on the design aspects of things. Now, we can expand this a little, the simple observation framework, just to give you a bit more meat on each of these things, people, places, and things. For example, you need to figure out, okay, what's the physical space that something gets used in? Let's take a ticket machine, for example, right? Where's this ticket machine being used? Oh, it's in the hallway of the main railway station, so very busy place. Not a lot of privacy. How is it laid out? These things become important, right? Then what are the actors that are involved, right? So you might have travelers going back and forth there and having to book last-minute tickets. Many people are under stress because they want to catch a train, right? When they book a ticket there. Then you try to figure out what they're doing, right? Okay, so they're booking tickets, but maybe one of them is trying to cancel a ticket or pick up a reservation or change it and whatnot. Then you will be looking at the objects that are in the space, right? There's, of course, the ticket machine, but there might be other things around. There might be a desk next to it where people can place their things, right? Or maybe there's no desk and you notice that people are struggling typing with one hand while holding their bags in the other hand. So you might learn something about the space and how to improve it as well. Then what are, specific individual actions? In the case of the ticket machine, you would notice, for example, maybe that people need to physically insert their Bahn card into a slot to sign in, for example, or that they need to pick up some tickets and change money from a slot at the bottom of the machine after they interacted with the screen, and the various interactions with the touchscreen itself. Then it's important to understand, are we observing a transaction that happens a lot? Do we see this happening again and again? Or are you seeing something that you could call a special event, like somebody booking the wrong ticket, for example? Right? Is that in a special situation that needs special attention as well? Or is, maybe once a day somebody comes by and has to book tickets for a whole class of school kids or something? And then, writing down and noting the sequence of events. How are things happening over time? What are the actors trying to do? So what is their end goal? Similar to the 7 stages of action, this is related to the activities that we've listed up there. But activities are things that you can observe, right? With goals, you probably need to talk to them and figure out, why did you come to the ticket machine? What is your goal today? What do you want to reach? And then getting a feeling on what the mood is of people using the system. If it's a group of people using it, then the mood in the group in general, and the mood of individuals in the group. So I'll give you an example here that is a short video about a study of using projectors. You may think that you know everything about how projectors work. But look at this video and you'll find it's actually a pretty deep, carefully done observation on how projectors actually get used and what the kinks are in the system, like what are all the things that tend to go wrong. I'm sure you've seen many of these issues yourself with projectors, but notice this is a particular way of looking at the world, right? This is not just going through everyday life and just suffering through the shortcomings of technology, but drilling down and trying to understand, okay, what exactly is going wrong here? And why might this be going wrong? Doing a bit of root cause analysis. For example, this analysis that, yeah, tech problems with projectors are annoying, but they become downright embarrassing because you're usually in front of an audience when you're struggling with them. We've all been in that situation. So this is not just observation, right? This is something, if you've gone out and watched people use projectors, just ask yourself, would I have come to the same conclusions? Would I have seen the same issues? Would I have noticed the same issues? And would I have paid the same kind of attention to the social interactions happening in the room, the various stakeholders, people, but also there's the technologies, there's the projector vendor, there's the the operating system manufacturer, and so on. So it's a good video. I think it's a good example because it shows reflected observation, right? The whole social context is being taken into account. And it shows that you need to take larger issues into consideration, like the privacy issues around displaying one's email on a big projector. We've all been down that route as well. So UI design is complicated. Congratulations, right? That's unfortunately true for almost everything you're going to do. It's way more complex than you initially think, and that's one of the things we try to teach in this class, to become aware of this complexity and to address it appropriately. This was another study done at Park, but that doesn't really matter. But Park is, has been for many years has been a great source of good, well done sort of mix of HCI research in the technical space and in the sociological space. So let's say you want to actually do an interview. You want to talk to people, right? Then you might wonder, okay, so how do I prepare for this? We can take an example. Let's say, Amazon, there's Amazon, they want to come up with, a new version of their Kindle, and they wonder whether it should also play back audio, like songs. So they go out and ask customers, right? That as an example. So let's assume, you ask people, for example, the interview goes out and you ask the person, do you listen to audio? And your user says, sometimes. That's not really helpful yet, right? But then you need to drill in a little bit more. Like, okay, so when do you listen to audio? While you're reading, right? This is assuming that you're using the reading device. Yeah, while I'm on the bus. And why is that? Okay, well, because the noise in the bus is distracting. And then the interviewer might ask, oh, is it always distracting? No, only in the evening when I ride home. In the morning, people seem to be, sleepy and quiet. So what you notice in this interview progress is that you are asking follow-up questions, right? You dig deeper based on the answers that you're getting from your client. So creating a protocol to make sure that you've got some points nailed down that you might want to ask is important. It's also important to not immediately jump on users and say, I'm going to tell you about this awesome new design that I'm making, and I want to hear your opinion on it. But keep it open, right? Try to understand the problem first before you start offering solutions or getting feedback on your solution ideas. This is tricky, right? Learning about the task often has nothing to do with the technology, and it's difficult sometimes to keep technology, especially your imagined solution, out of it, to really have an open mind and understand the task well. Again, pilot interviews help, where you just interview one person inside or outside your group, for example, and usually you have a separate person observing any pitfalls, right? You are in the interview with a person, and then a third person takes notes and makes notes of anything that seems not to go smoothly. So don't just listen to the answers, but ask follow-up questions and dive in there. This is one of the techniques that is important. Your questions should be clear and simple questions. They should not be guiding people at all. So how do you like the UI is way too general, right? It could be an icebreaker initially to get people going, but you need to become more specific after a while. Also understand that people don't always answer truthfully, right? And this has nothing to do with people willingly lying to you because they're bad people, but there's a couple of reasons for this. One is people often don't know, right? If you ask people, so how many hours do you spend on Facebook each day? And they're like, oh, I don't know, an hour maybe. And when you then actually were to take the measurements, maybe you find it's 3. And people maybe just didn't realize the time they spent there. Or at least they estimate badly, but also sometimes they're just embarrassed, right? So they may not answer truthfully because they don't want to acknowledge something. So you got to formulate your questions carefully, maybe even indirectly, right? And there was once a wonderful example for this kind of thing going wrong, where there was an interview done with people in the UK, and they asked, so how many, to adult people, how many different sexual partners have you had? And it turned out that those people who reported themselves as women and that had been interviewed, this is quite a while ago, had significantly fewer sexual different partners than the men. And yes, we can, even if you try to, admit for some noise in the system here, overall, this doesn't quite work out, right? So there's something going on here where people are self-reporting things because they want these things to be what others think about them, right? So formulate your questions carefully. Sometimes you have to ask indirectly, but this doesn't mean that you should be leading, right? So don't bias the user when you ask questions. Like, for example, if you want to ask if we should add audio playback to an ebook reader, if you say that, then that's a leading question, right? Do you want audio playback in an ebook reader? Well, unless people are very, adamant about it, they're probably going to say, sure, sounds fine, thinking, well, I won't have to use it if it's there, right? So that's not the right question to ask. You need to be asking things like, do you listen to audio while you're reading an ebook, for example? That's a better way of asking this kind of thing. Now, once you've got your results of your interview, you might end up with a user profile, a profile of the task that people are doing, and if there's a system involved, then you will understand problem areas with using the system and ideas for improving it. Right? Those are the typical things you draw out of an interview. In our case, the idea for that we're looking for initially is, what is the task that our system should be supporting? So now we've got, let's assume you've done some interviews with users to understand the task better, and you want to aggregate this in some way. You want to sort of, put this together. For users, there's actually a nice way of doing that, and that format is called personas. Personas are precise descriptions of users, but they are not real people. So they are made up people, but they are aggregated from the observations you've made about real people. So they act as a stand-in for a real user because of privacy issues. You usually don't want to share, the actual individual person that you've interviewed, obviously. But this persona, since it's a made-up person, can help you act as a stand-in that situation. So it's a hypothetical but a precise description of a typical user. And this will help you guide your design decisions. When you're sitting down, with your development team, and you're like, okay, so do our users want to listen to audio while they're on the bus or not? Then you can say like, well, our persona here, we've written down had this opinion on it, or has this, this preference for this kind of thing. So they're fictitious, but based on knowledge of real users from the observations. A great advantage of personas is that they are pretty specific. So they are not what people call elastic. Elastic is a bad thing for a user profile. Elastic means that you imagine a hypothetical professional business user, and then that user magically will fit any needs that you find you have during your design process, right? So you never have any issues with that user that you identify, because they always fit sort of your profile of skills and preferences and motivations and so on. So here's an example that I'm gonna zoom in on here. This was done in looking at a problem around social media, and here's an example of a persona. Ginny, you see some background here. 15, female, ongoing private education, ambitious, comfortable using tech to communicate. Some of her motivations: keeping in touch with her network of friends, fashion, street cred, keeping up with peers, and so on. And some frustration: sad people trying to be friends on Facebook, having to be in bed at 11 p.m., being swamped in friends updates, and missing important status updates. And here's this was the sort of the short list here on the left, and then in the middle you've got a little more detail on it. What she does, enjoys playing some kind of sport, is good at art, loves recording her favorite shows, blah blah blah. Spends some time on the laptop that Daddy bought her, watching videos on YouTube, downloading music, and so on. And has some, fashion preferences and so on. So, and there's a quote even, and a picture, right? All of these are fictitious, but overall, you now have a picture of a person. And now if you ask yourself, okay, so should we try to include a link to, I don't know, sports news in our social media website, then you can pull out the Ginny persona and say, well, Ginny would like to, maybe see this because of her interests and her statements that we've associated with her as a person. Okay, so that's the idea of personas. Sometimes you get by with one, but often you need a few of those to also capture the heterogeneity, the mix of people and the differences among people that are still supposed to be within your target user base. All right, so we got some idea on how to talk to people, how to pull out what we learn about people into personas. Now on to how do we formulate solutions for the task and issues and needs that we've discovered. Brainstorming is one of those techniques. It's an initial design technique that you use very early on in the very early cycles of your DIA cycle. And the goal of it is to collect as many ideas on a topic as you can. It should be a relaxed activity, you should have fun. It's a good idea to invite people that you've identified as good brainstormers. Some people are better at this than others are. And one of the key rules of brainstorming is that you're collecting ideas without judging, right? So you don't criticize, you don't argue. I know we're all Germans, or many of us, and we are really good at criticizing, right? So turn off that German criticizing gene if you have it for a moment. And try to be open to any ideas people are throwing out there, right? Don't wear your black hat right away. This may be tough for some. Instead, what you want to do is if somebody proposes something and you think, well, that's not a good idea, but maybe it gives you an idea for something better. So you can leapfrog on that, right? Or if somebody proposes something that you think, oh, that's great, and we could do this with that as well, right? So you try to build on each other's ideas and energy here. You go for quantity and not quality, right? You include crazy ideas in your designs. You don't just go for things that are carefully vetted ideas. You throw everything out there, right? For example, you can go for like 100 ideas in your brainstorming, in your session. It's often a good idea if you have a group of people brainstorming to have a scribe that collects the ideas visible for everybody, meaning that if you're in a group with 5 or 10 people and everybody's tossing out ideas, shouting them out, then one person stands at the whiteboard and just writes them down as fast as they can, right? Because the advantage of that is that everybody else doesn't have to worry about writing them down. They just can generate ideas, and everybody sees all the input emerging in front of them being written by that scribe. Now, this is a high energy task. you want to limit brainstorming to like very few minutes, right? Maximum 5 to maybe 10 minutes. After that, people tend to be, just, drained. Don't do it for an hour, you'll die, right? Not a good idea. The idea of brainstorming is to really push you sort of to come up with ideas beyond the generic thinking. One way to do that, for example, is let me see whether I have an example of that here. Yeah, you can think of habits, for example, positive habits or negative habits. You can think of physical gadgets and how the habits can be linked to them. You can try to stick to a particular domain, for example, diet or exercise, drinking, smoking, hygiene, etc. And you can try to answer the who, what, where questions, which is a bit like the context, task, and user, right? So who is the user, what's the task, and where is the context. Once we've structured we've received our brainstorming input. So first of all, I mean, this was incredibly short time and there was a lot of technical difficulties and you're much slower typing in and creating little sticky notes than just shouting out an idea. So sorry about the technical limitations here. Maybe you got a few ideas on the board, even just, a few is fine. You can continue adding new ideas in the next phase here. What we're going to do now is what's called concept mapping. This is to structure what you found out in your brainstorm. This is a technique that's been used forever. In the Middle Ages, Spanish monks have used it, and the name mind mapping used to be used for that, but that got trademarked by a guy in the 70s, so people now call it concept mapping. It uses, the advantage of doing concept maps or mind maps is to use both brain sides. It helps you to structure notes that you take for overview or for planning or for learning, and it gives them a visual, you could say gestalt, a visual shape. And this is super useful to do once you're done with this, because it gives you a much more, something that is much easier to remember. If you do this on paper, you would use like an A3 piece of paper, so a big one. You would put the topic of your brainstorming session in the middle and of your concept map. And then you would put different branches out from the center. And each of these branches would be one aspect of the ideas that you've generated. So maybe you've created some ideas of particular users. Maybe you've created some ideas that are around particular devices or some ideas around particular tasks or locations. So you'd group it like this. And then beyond those, there would be subtopics on sub-branches of this. When we normally teach this class in person, we do this with pencil and paper and color pens and so on, because the analog medium is incredibly low threshold, right? It doesn't take a lot of effort to just scribble something down or take a sticky note and just jam it down on a piece of paper. It's very fast, very effective for this kind of thinking. So don't over digitize this when you are in an in-person meeting. Now we're doing this virtually. And so what we've used is this tool called Concept Map that is a little clunky to create the brainstorming ideas maybe. But now in the next phase, it will actually help us a bit because it lets us directly connect our ideas into this kind of map that we're talking about. Usually a concept map can be thought of as a tree from a computer science point of view, with the root in the middle and then the leaves going, the branch and the leaves going out, the leaves being on the outside. Although it's totally fine and often very useful to, once you've established your basic tree structure, to add additional connections, relationships with arrows in there as well that may point to, from one leaf and one branch to another leaf, and they might be somehow related. Maybe they're both about like a medical application area and you haven't, but you've classified them differently, let's say. Maybe you've got a doctor as the user and maybe you've got a hospital as a location, and you would link those two with an arrow, for example. It also helps a lot to use images or icons for keywords when it makes sense, right? You don't need to push this hard for everything, but if there is a good graphical representation of an idea, like a hospital, there's a little icon for a hospital, easy enough to find, or for a doctor, you can use emojis or whatever you do. And you can even, if you have some drawing talent, then you can even scribble these yourself and just put them in there. The point is, when you add these images, it's way easier to remember your map and to make a visual image of it, a photo in your head, than if it's just a wall of text, right? So anything you add to it that makes it look different from the next concept map next door, so to say, is good. You want to make it unique. You use colors to highlight things. For example, you can use like a blue color for all your locations and a red color for the branch with all your people, for your users, etc. Oftentimes, these colors are used to highlight branches or to mark up connections after a pencil version has actually become somewhat stable. A concept map is not a one-time thing. Once you've created it, you can actually often work on it, and it can grow over time. And you can sometimes even combine individual maps from individual people, for example, that have thought about different aspects and make them into a larger concept map. The point of the concept map in general is just to give you a visually sort of distinct and unique representation of your topic, right? Here's a concept map that is about interactive, large public displays. And you don't need to be able to read every detail in this map here. But what you can immediately see is that the map has different main branches, right? It's got a branch around entertainment here on the bottom, and it has got this like smiling lips, mouth thing here next to that. It has an area around information, and that has a little light bulb drawn into it. And it has an area around socializing, which actually has two hands, being held here next to it. And down these lines, there are sort of subdivisions of these different things. So, for example, socializing is branched out into dating and conferences and other things here. And you can see that people have the designers of this concept map have used little icons, little sort of drawings. For example, down here is music, right? You can see with the microphone, or here's a pencil down here on the right for drawing and painting. So it's attempting to put little icons in there to make it more memorable, right? We can also see that the main graph branches are these different branches, and then there are sometimes, then they go into sub-branches and sub-branches and sub-branches. And here are links between these different branches as well with this arrow connection here is also indicated. Graffiti down here, for example, is shown. So all the different aspects and ideas around large interactive displays are mapped into this thing. So what we do with this is we use your visual memory to memorize things and to think about things in addition to your verbal memory that is really good at dealing with words and lines of text and so on. So your next exercise, your next in-class exercise is now to take your existing ideas and maybe add some more to it and to create this concept map based on the key problem, right? Cleaning your room or motivating people to clean their rooms. And then you can start putting your ideas into a concept map and add some more to it as well. I hope you had a bit of fun with the concept mapping. I know time is short, and this is really just to give you a sneak peek of the activity, right? This will be in much more detail when you actually work on your assignments these upcoming weeks. You'll be doing more of this kind of stuff. So now we have a concept map of our ideas. We assume that we've sort of done some user analysis for your project. Now the next thing that you need to do in this is all sort of very early design activities, right? We haven't done any testing yet. All we've done is we've talked to users, which you could consider a first analysis phase, and we've maybe with storyboarding we've created a few ideas. So that's the design step. And now, how do you implement that? Well, you don't implement it by starting to code. You don't implement it by writing. You can implement it by just drawing a storyboard. You know storyboards from comics. And storyboards are a great way to communicate what a user is doing with the system and what your idea of the interaction is. And you're going to draw the storyboard to show it to people and to get their feedback on it. So a storyboard is a sequence of images like a visual outline of a film. It visually represents a script, and it illustrates the interaction happening in there. That's what the storyboard contains. We do this because in a storyboard, we can really nicely describe a task, show an environment where people are, show a user, and also show the computer, or replace computer by technology, whatever it is, interactive system. You can also have storyboards that don't have this like a zoomed out view of the user as a whole, but that actually then zoom in on the user interface and show as a storyboard, as a series of images, screenshots from a UI without the environment. But we're going to get to those later. This is not what you do in your first step, because early on, you want to make sure that everybody understands what the overall situation of the technology in context is. It really helps to work out details about your interaction. It's a great at-a-glance overview that anybody can scan in like 30 seconds and get what your interface, what your system is all about. And it really helps to develop later usage scenarios where you write maybe more text, flesh out the tasks, and ultimately flesh out the tool or solution that you are proposing. So when should we do this? We should do storyboarding after describing a task. Because when you storyboard it and then take it back to the user, you can show it to them, talk them through the storyboard, and see if you got the story right. So this is basically helping you understand what people want to achieve, right, with the system. Let me show you a little example. When I taught this class at Stanford University, one semester, we gave our students the assignment to come up with technology that helps people in in their everyday social interactions, not online, but in real person. And I don't know, it's probably something to do with computer scientists, but somebody always suggests to wear glasses that, tell you who other people are. Seems to be this limitation of us computer scientists that we are not very good at recognizing other people and remembering their names. So again, these students proposed this kind of system. And they drew a little storyboard to illustrate their idea. And here it is. I'm going to talk you through it. Don't worry so much about the system, but pay attention to how I can pitch this idea to you really quickly by walking you through the storyboard. At the top, we got Bob walking around somewhere, and Bob's on the right, and he encounters somebody else, and this other guy says, "Hi, Bob," and Bob is like, "Oh, crap, who is this person?" Because Bob never remembers faces, right? So he is like, how is your wife? And this other guy's like, "What wife? I'm not even married," right? So Tim is highly annoyed because Tim thinks, Bob is a moron. He doesn't remember him, although he should know him. That's the bad way, right? Without recognition. But if Bob had recognition glasses, then here's, Tim walking into Bob, and Tim says, "Hi, Bob." And, Bob sees in his glasses, "Oh, this is Tim Brown. Awesome." And the glasses register, they recognize Tim's name. And then, Bob says to Tim, "Hi, Tim, how is your startup doing?" and so on. So because Bob remembers Tim, and Tim Brown's startup, brown.com, the discussion goes on great, right? So Tim is like, "Oh, it's doing great, want to catch some coffee later," and so on. So everything is great, right? So you can see all of a sudden things work out smoothly. See, I could communicate a particular usage scenario to you, what the user can do with this very quickly by having the storyboard. Now, I know, even though I don't see all of you, I can literally feel the anxiety in your eyes because you all think that you cannot draw, or most of you probably think that. And we're going to fix that, right? So last part of today's class is going to be how to draw people. I'm going to do an interactive little drawing session here with you guys that will show you, I can't draw either to save my life, but I found a couple tricks to make it look like I could draw. What I want you to do is get out a pencil, get out a piece of paper right now, and start drawing with me, okay? You need something like real paper, real pencil. If in a pinch, you can also use your tablet if it has a decent pencil, but it really works best if you have a piece of paper in front of you, and just draw, okay? So everything I draw, I want you guys to follow along with and just doodle in a similar way that I'm doodling it, okay? That's the idea here. So let me start by explaining to you what Starman is. So when you're asked to draw a person, many of you are probably going to be drawing something like this. Hold on, I'm going to pick a pen here. There we go. Right, you probably draw things like that, and that's okay. But we can do better, because stickman is kind of lame, right? That's how you were drawing people when you were like, 5 years old. And I don't know about you, I haven't moved much beyond that from my natural abilities, but I'm going to show you a better way to draw people, simply because you can be more expressive with what I'm going to show you. Instead of stickman, you're going to draw starman. So what I want you to do is draw a 5-edged star to begin with, which looks like this. 1, 2, 3, 4, 5. Okay, that's not so hard. It's Christmas season, right? You'll be able to do that. And now we're going to distort that a little and make it into a person, right? So keep drawing, right? While I'm talking to you, keep drawing. Don't just watch me. So it looks like this. You make this a hat, like the head, sorry. Then you got an arm, and then you got a leg, and then you got another leg, and then you got another arm. Okay, that's almost a person, right? And it's already better than having stickman, because it actually has a, it has a volume of a body that is non-zero, to be mathematical about it, right? And you can also do things with starman, right? You can do, this is kind of maybe a sad starman, but you can also have a happy starman that's like, he has his arms up like this. He's like, yay, I'm so happy. And you give him a little smiley face here. Can put some eyes in there too. You can have starman can even be pressing a button. So for example, here's starman, if you draw him like this, and then he's got his arm out here, and his other arm is over here, and he's like pressing this button on the wall, right? So he's interacting with stuff, right? Yeah, these do look a little bit like Ku Klux Klan sometimes, so I'm sorry about that, but that's, that's the price you pay for starman. Starman can be can be a whole family if you want to, draw them. So you can have like one guy here. Okay, he got a little bit off here, I guess. And then there's like a second one like this. And then you can have like a tiny little.
Yeah, sorry.
Yep.
The screen sharing stopped for some reason.
Okay. Let me see what's going on. I'm going to try to get that back. That's probably Zoom just messing with me, I guess. Share screen. Start. All right.
Yeah, we're back.
Let's see. You are sharing screen. How's that?
Yeah, it's working.
Back at all? No?
Yeah. Yes.
Oh, it is.
Do you hear me?
Yep, got it. Seems to be working now. Okay. All right. So this is a little, happy family here. If you sometimes, if you want to draw lots of people, you want to simplify even further. So you can also do Star Trek Man, right? Star Trek Man is basically, the Star Trek logo, right? And so you can draw people very, very simply by just putting a, oops, that's not a good pen, by putting a head and then just putting, a little figure like that, like the Star Trek logo beneath them. These guys don't have arms, right? So that's a little bit of a limitation, but they are a little faster to draw, right? They take less time. So if you need to fill in like an appreciative audience or something, or like a group of people queuing in line, then oftentimes that is already enough, right? To show just there's people. And this already looks a bit better than just drawing stickman, right? You can even be even simpler. You cannot close the Star Trek logo at the bottom and just do it like this. And then you have like the super simple version of it, which is this, right? These are like 4 people in a row. You can create a whole audience, right, in a room with this really quickly. And then there can be like a person maybe up here who's like, presenting something, giving a talk, and he's like talking to his audience, and that gives you a quick setting of your context. You could put people around an exhibit, right? There could be lots of people. Also, maybe here there's backstanders, looking at at a person who is in front here and who is like waving a baton at a conducting exhibit, something we built a couple years ago. And he's interacting with a large screen that's standing in front of him somehow. So this is a way to sketch the environment, right? Now, sometimes you want to be cool and you want to, look like an architect. And if you can't afford the black, turtleneck sweater, then you can at least draw Architect Man. Architect Man is a scribbly version. And for that, I think I need to use maybe a different pen here that doesn't do the autocorrection. Kind of looks like that. So if you do this, these kind of figures are also ways to sketch people. And see, like I can't draw, but these look really cool. Like I'm a cool architect, right? And can draw these things. And if you want to create then an environment, you can also, if somebody says, but there has to be a tree, right? And you're like, okay, I can do a tree as well. It's like this. And then here's a tree, right? And now I've got a tree and I've got 3 people, right? So this is a very easy sketching technique that you can use. Or if you are bound to draw business people, for example, people in suits, right? Then there is a way to draw them like this, right? These are like typical suit-wearing people. That's another way to draw folks. And this is all about people. The tricky thing now is, of course, often we have interactions going on where we need to draw a hand, and the hand is terrible, right? So your average, I'm going to create a new page for this. Hold on. Just add another page to that. There you go. When you need to draw a hand, people are like, okay, I can draw a hand. It's like 1, 2, 3, 4, 5, right? That's kind of like your average, like 5-year-old hand. We can do better than that. A good hand is you basically just make sure that you get like roughly the right number of digits with a figure like this: 1, 2, 3, 4, 5. And that's already a hand that is like, for example, pushing a button, right? Very easy to do this, do it that way. So that's one way of drawing a hand. If you want to draw hands that grasp things get a little more complicated. I've got a longer video for you that we're going to share with you to do that. But what I want to illustrate with this is you can build yourself a vocabulary, right? It also helps to have quick ways to draw other things, like draw an idea, right? So you should be able to maybe quickly draw like a light bulb, right? Even though those are kind of dying out, but people still understand that a light bulb is kind of like your typical, way of communicating an idea, right? So learn how to draw that quickly as an icon, as a communication tool. You should be able to sketch while you're talking about your idea, right? It's a good way it's good to know, icons for a number of these things, like maybe understand how you draw a file, right? There's a standard way to draw a little file, like, with this little folded in edge here, that logo from your computer, right? That's a great way to draw a document. And it really only takes you to look at these things consciously and practice a little bit of an icon for that. There's lots of books out there for like sketching on napkin sketches and so on. Urban sketching goes in a similar direction, rough sketches, quick ones that go out at a moment's notice. So what I'm trying to teach you is not an art form in the sense that I expect you to do beautiful drawings, right? This is a communication skill. It's a communication skill that's just as important as talking to people. A wonderful person, Bill Verplank, was one of the original designers of the Xerox Star user interface, the one that we saw a couple of weeks ago in the history class. He also happened to be at Stanford when I was there, and I had the pleasure of teaching together with him and watch him do his drawing classes. And at some point, I managed to convince him to come to Aachen and give us a drawing class in person live here. And that was a wonderful event. We've got a recording of that, which we'll be sharing with you. And so he's so much better than I am in drawing these things. It's a delight to watch him do this. The key point, however, is that when you sit down with Bill and you have a meeting, you end up with a bullet point list of things, and he ends up with a whole board full of drawings, right? He puts everything into graphical form, and it's much more memorable that way. So that's how you basically draw users. And after this little drawing interlude, like I said, the video of Bill Verplank doing this, we will show you. We'll show you next time. Couple more references on storyboarding apart from that video from Bill Verplank. There's also other examples. You know, in the Art of Human Computer Interface Design is a book that actually has a lot of these starman drawings in there. There's a good book if you want to learn drawing from Betty Edwards, Drawing on the Right Side of the Brain. And you can do storyboards digitally, but manual sketching is still essential whenever you have a meeting where you're discussing ideas or discussing design decisions. This is a crucial thing to be able to do. So we're at the end of the time here today, so I don't want to push into our overtime. Therefore, I will leave the in-class exercise out for drawing the storyboard, right? The idea for that would be hold onto your concept board and take that idea from the concept board. You can do this at home in your own time and draw a very, very simple storyboard for your preferred brainstormed idea. It's a quick exercise. It shouldn't take you long. A few things about how to do this. It's usually a great idea to limit yourself to maybe 3 frames in your comic. The first one kind of sets the scene and introduces the problem. The second one then shows how the technology is at work, what it does in some way, how the user interacts with it. And then the third one shows the happy ending, basically, when people use the technology successfully and were able to work with it. It's usually a good idea to put little subtitles under your storyboard, just like you saw with the example with the recognition glasses, so that you and others can sort of read the annotations to it. It's a good idea if you can make it readable from a 2-meter distance, right? So use a big piece of paper, do 3 frames on it, don't get too detailed, make rough sketches. And then once you've sketched things out with a pencil, go in and use a black Sharpie or like a felt marker and edding to mark up the key lines of your drawing, right? Not everything, but the key outlines of people and objects and the frames. So then it will become really easy to read and recognize and be bolder than if you just have this, pencil shaded pencil drawing on there that nobody can tell apart from 2 meters distance. What we usually do, and if this happens in live sessions, that we do like a walk around fair where everybody gets to look at other people's drawings and learn about the ideas that they developed. We can't do that here. We also don't have time for doing the sharing via Zoom here, but I encourage you to do a little doodle of your preferred idea from this brainstorming. And then maybe there's a way to share this in the next session when you guys have a lab session. That will be happening during the lab. And with that, I'm done for today. This concludes our sort of first introduction into this general third topic area, right? The development process. We've talked about the DIA cycle. I've given you guys an idea of how the iterative design cycle works. You've seen some initial tools on ideation, like brainstorming. We've talked about the very first version of prototyping, which is actually that storyboard. That's your first prototype, your first implementation in the DIA cycle. Could very well be such a graphical storyboard. And you'll hear more about how you evaluate these and other prototypes and how you create more kinds of prototypes in the upcoming classes. Thanks everybody for listening. We won't have a class next week because that's the 23rd of December and you're all supposed to be very much on Christmas vacation by that time already. So I will be seeing you guys again next year after the Christmas break. We start in the first week of January on Wednesday, I think it's the 6th. We will have our next DIS1 class continuing this topic. Thanks everybody for joining and have a great rest of your day.
This content was provided by RWTH Aachen University.